Chapter 4, Heat. Lesson Preview. Hot and cold. Measuring temperature. Transfer of heat. Conduction. Convection. Radiation. We feel hot in summer and cold in winter. In the hilly areas, it is cold throughout the year. In winter, we wear woolen clothes to keep us warm. We love to sit in the sun in the afternoon. In summer, we wear light-colored, loose-fitting cotton clothes. We do not feel like going outside because it is hot. Even inside the house, we feel hot. How do we know if an object is hot or cold? How do we find out how hot or cold an object is? Let us try to find out the answer to these and many more such questions. Hot and cold. When we rub our palms against each other, they become warm. One of the methods to determine whether an object is hot or cold is by the sense of touch, but this is not a very reliable method. In our day-to-day life, we come across some things that are hot and some that are cold. Some objects have been listed in the table given alongside. Identify if they are hot or cold by putting a U-diaresis tick mark in the appropriate column. Some objects are colder or hotter than others. Heat is a form of energy which causes the sensation of hotness or coldness. Activity 1. Take 3 glasses. Label them as 1, 2 and 3. Fill glass 1 with cold water, glass 3 with hot water, and pour some warm water in glass 2. 2. Dip a finger of one hand in glass 1 and that of the other in glass 3, as shown in the figure. Keep the glass 2 containing warm water in between the 2 glasses. After keeping the fingers in glass 1 and 3 for 2-3 minutes, put both the fingers into glass 2. 3. What do you observe? Do both the fingers feel the same thing? You will know that one finger feels water is hot and the other feels that the water is cold. But actually the water is neither hot nor cold, it is just warm. Precaution: do not use very hot water as it may burn your fingers. This shows that the term hot and cold are relative terms. We cannot always rely on our sense of touch to decide whether an object is hot or cold. To overcome the above problem, we need to measure the temperature of an object. The degree of hotness or coldness of an object on some chosen scale is called its temperature. We measure temperature with the help of a device called the thermometer. Measuring temperature. You must have seen a doctor or your parents measuring your body temperature with the help of a thermometer when you were having fever. Our body temperature is measured with the help of a clinical thermometer. It is also called doctor's thermometer. Look at a clinical thermometer and examine it carefully. A clinical thermometer consists of a long, narrow glass tube. It has a bulb at one end, which contains mercury. A small shining thread of mercury is seen in the glass tube outside the mercury. You will also see markings on the thermometer, which show the temperature between a range. Range of a clinical thermometer is between 35 degrees Celsius to 42 degrees Celsius on the Celsius scale, while it is between 94 degrees Fahrenheit to 108 degrees Fahrenheit on a Fahrenheit scale. However, India has adopted Celsius scale. Bulb. Glass tube. Reading a thermometer. First determine the value of one small division on the thermometer scale. Count the number of small divisions between 2 bigger marks. Suppose the bigger marks read 1 degree and there are 5 small divisions between them. The value of one small division equals 1.5 equals 0.2 degrees Celsius. Precautions to be observed while reading a clinical thermometer. Wash the thermometer well, preferably with an antiseptic solution both before and after use. Hold the thermometer from its top end and read the mercury level. Ensure that before use, the mercury level is below 35 degrees Celsius. If the level is above 35 degrees Celsius, bring it down by giving a few downward jerks to the thermometer. Place the bulb of the thermometer under the tongue for 1 minute. After 1 minute, take the thermometer out and note the reading. Read the thermometer keeping the level of mercury along the line of sight. The reading obtained is your body temperature. Be careful while using a thermometer. It can break easily. Do not hold the bulb while noting down the temperature. The average normal body temperature is generally accepted as 37 degrees Celsius or 98.6 degrees Fahrenheit. Always remember to write down the unit. Is the normal body temperature exactly 37 degrees Celsius for all individuals? Let us try to find this out with the help of an activity. What do you observe? Is the temperature of all your friends exactly 37 degrees Celsius? The temperature could be slightly higher or even lower. The normal body temperature is the average body temperature of a large number of healthy persons. Since the range of clinical thermometer is 35 degrees Celsius to 42 degrees Celsius, we should not use a clinical thermometer to measure the temperature of any object other than the human body. Laboratory thermometer. Different types of thermometers are used to measure the temperature of different objects. Laboratory thermometer is one such thermometer. It measures the temperature in the range of 10 degrees Celsius to 110 degrees Celsius. There is another type of thermometer called maximum-minimum thermometer which is used to measure the maximum and minimum temperature of the day. You must have read about the minimum and maximum temperature of different cities in weather reports in newspapers. Let us now learn how to use a laboratory thermometer. Carry out the activities under the supervision of an adult. Activity. Take some water in a beaker. Dip the thermometer in the beaker containing water. Ensure that the bulb is completely dipped in the water and that the bulb does not touch the bottom or the sides of the beaker. Observe the mercury thread in the thermometer. Record the temperature when it becomes steady. Precautions to be followed while using a laboratory thermometer. The thermometer should be held in a vertical position. The bulb of the thermometer should be completely surrounded from all sides by the substance whose temperature is to be measured. The bulb should not touch the bottom or the sides of the beaker. Reading should be taken without removing the thermometer from the substance. Reading should be taken only when the mercury thread becomes steady. The eye should be kept at the level of mercury thread. Activity. Take a beaker. Put hot water in it. Dip the laboratory thermometer in it. Note down the temperature of water once the mercury thread becomes steady. Now take out the thermometer from the water. Keep observing the mercury thread. What do you notice? You will notice that the level of mercury starts falling down as soon as the thermometer is removed from the beaker. This is the reason why the reading has to be noted when the thermometer is dipped in water. However, when using a clinical thermometer to measure body temperature, we have to remove it from our mouth to note down the temperature. Now you know the answer as to why we cannot use a laboratory thermometer to measure our body temperature. The clinical thermometer must be having some special feature because of which the mercury does not fall or rise when taken out of the mouth. This is because a clinical thermometer has a kink or constriction in the tube near the bulb. This kink ensures that mercury in the thermometer does not fall down immediately after it is taken out of the patient's mouth. The temperature can therefore be easily read. The level of mercury thread can be brought back by giving the thermometer a slight jerk. Nowadays, digital thermometers are available. The advantage of such thermometers is that they do not use mercury. Mercury is a toxic metal and there is a problem of its disposal in case the thermometer breaks. Transfer of heat. When you keep a cooker on the gas, it becomes hot. In fact, the handle of the spoon with which you stir vegetables in a pan when kept on a flame also becomes hot. Why does the handle of the spoon become hot? When you remove the spoon from the pan and keep it outside, it cools down. Why does it cool? This is because heat is transferred from hotter objects to colder objects. This heat transfer continues till both the bodies attain the same temperature. When a hot body and a cold body come in contact, the hot body loses heat, while the cold body gains heat. Activity. To show conduction of heat, take an iron rod. Fix 4 drawing pins on it with the help of wax at nearly equal distances. Place the rod between 2 bricks as shown in the figure. Heat one end of the rod with a candle. What do you observe? You will see that the pin nearest to the candle falls down first as the wax melts. After some time the second pin falls down, and this continues. Conduction. The activity shows that heat travels from the hotter to the colder end through conduction. In solids, heat is generally transferred by the process of conduction. As we know, the molecules of a substance start vibrating faster when heat is supplied to it. Thus, when one end of a metal rod is heated, the molecules at that end start vibrating faster. They hit the nearby molecules and make them vibrate. These molecules again hit their neighboring molecules. In this way, heat gets transferred from the hot end to the cold end of the rod. Thus, conduction is the process of transfer of heat in which heat travels from molecule to molecule, from the hot end towards the cold end. The molecules themselves do not travel from one end to the other. Heat is, however, transferred from one object to another by conduction only if the 2 objects are in contact, and their temperatures are not the same. Good and bad conductors of heat. Substances which allow heat to flow through them are called good conductors of heat. Some substances do not allow heat to pass through them easily and are called bad conductors of heat or insulators. Metals like iron, copper, aluminium, etc. are good conductors of heat. Wool, plastic, cotton, glass, wood, clay, rubber, bakelite, etc. are some examples of insulators. Activity. Take a beaker. Fill it with boiling hot water. Take some articles made of the above-mentioned materials. Dip one end of these in hot water. After a few minutes, touch the other end. Note down your observations. Remember, water and air are poor conductors of heat. Both conductors and insulators are useful. Cooking utensils are made of conductors, metals, and their handles are made of insulators, heat-resistant plastics. Uses of good and bad conductors of heat. We use good conductors of heat wherever we want heat to be transferred quickly, such as cooking utensils. These utensils are made of metal such as brass or aluminum, which are good conductors of heat. Silver and copper are also the good conductors of heat, but cooking vessels are not made of these metals as they are expensive. Cooking vessels having copper bases are however available in the market. Jute and sawdust are bad conductors of heat. We cover ice with a jute cloth, sackcloth or sawdust, to prevent it from gaining heat from the surroundings and melting. Refrigerators have double walls filled with insulating material. This prevents heat from the surroundings from entering into it. We wear woolen clothes in winter because wool is a poor conductor of heat. Insulator. It allows body heat to be trapped inside. Moreover, the air present in between the wool fibers prevents the flow of our body heat to the surroundings, so we feel warm. Thus, wearing too thin sweaters makes us feel warmer than wearing a thick sweater because there is an additional layer of air between the two sweaters. Convection. When heat is transferred in solids by conduction, movement of molecules does not take place. In liquids and gases, heat is transferred by convection. The method by which heat is transferred from the hotter part to the colder part of a medium by actual movement of molecules in it is called convection. Activity. To show convection current in water. Take a beaker, fill it with water up to 2/3. Gently place a crystal of potassium permanganate into the beaker. Heat the beaker with the help of a Bunsen burner. What do you observe? When the beaker is heated, water near the flame becomes hot. It rises up, purple-colored. The cold water from the sides moves down to take the place of this water. Again water when heated rises, and again the water from the sides moves down. This way, the whole water gets heated. This activity shows that water transfers heat by the movement of molecules from hotter to colder areas by convection. Activity. Take a candle, fix it on a stand and light it. Keep your palm on the top of the flame at a safe distance so that it may not get burnt. Keep the other palm at the side of the flame. What do you notice? You will see that the palm above the flame feels quite hot, whereas the palm at the side does not feel as hot. This shows that air gets heated by the process of convection. Sea breeze and land breeze. In coastal areas, the breeze blows from the sea to the land during daytime and is called sea breeze. This is because during the day the land gets heated up faster than the water. The air over the land becomes hotter and rises up. The cooler air from the sea moves towards the land to take its place. At night, exactly the opposite takes place. The land cools down faster than the sea water. The air over sea is now warmer. It rises up and the cooler air over the land rushes in to take its place. Therefore, the cool breeze from the land blows towards the sea. This is called land breeze. This is the reason the windows in the houses in coastal areas are made to face the sea, so as to receive cool sea breeze during the day. Applications of convection. In houses constructed in earlier times, ventilators were provided high up on the walls. This is because the air we breathe out is warmer and lighter, and thus rises up. This warm air rises up and escapes through the ventilators. This warm air is replaced by heavier air which is fresh and comes from outside from windows and doors. This is done by coolers. Thus, warm and stale air goes out from the top while fresh air comes in from below due to convection currents set up in the room. Central heating in buildings is based on the concept of convection currents. Usually water or oil is heated in a boiler. This sets up convection currents in the water or oil because of which it circulates through pipes that go through rooms. Radiation. You must have noticed that we feel warm when we move out in the sun or stand in front of a flame. How does the heat of the sun reach us? This heat cannot reach us by conduction or convection as there is no direct contact between us and the sun. There is no medium such as air in most part of the space between the sun and the earth. Moreover, hot air rises up. This shows that there is another method of transferring heat. This is called radiation. Radiation needs no medium. It can take place even in vacuum. It is because of radiation that we get heat when we sit in front of a heater in a room. All hot objects/substances, solids, liquids and gases, transfer heat by radiation. Our body also gives heat to the surroundings and receives heat from it through radiation. The higher the temperature of a body, the more heat it radiates. All objects radiate heat. When this heat falls on objects like trees, soil, water, human beings, etc., some of it is absorbed, some is reflected, and a part of it is transmitted. The amount of absorption and reflection of radiant heat depends upon A. the nature of the surface, and B. the color of the object. Activity. Take two identical cans. Paint one of them black and the other white from outside. Fill the cans with water. Ensure that the amount of water is the same. Leave the cans in the sun in the afternoon for an hour. Measure the temperature of water in both the cans. What do you observe? In which can is the water warmer? Now heat both the cans to the same temperature and keep them in shade. Note the temperature after every minute. Which one cools down faster? This activity shows that the black surface absorbs or radiates more heat than the white surface in the same period. Activity. Now place the two cans used in the above activity inside the room. Leave them undisturbed for 15 minutes. Again note down the temperature of water in the cans. Do you notice any difference? You will see that the temperature of the water in the black can falls more rapidly than that of the white can. These experiments show that a black surface is a better radiator and also a better absorber of heat than a white surface. Applications of radiation. Electric room heaters are provided with a polished metal surface behind the heating element. This surface reflects almost all the radiant heat from the heating element that falls on it. This makes the room heater more effective. The outer base of a cooking utensil is painted black so that it may absorb more heat. This cooks food in less time. The back of refrigerator is painted dull black to radiate heat more effectively so that refrigerator pipes may cool down more quickly. White and light-colored clothes are more comfortable in summer as they reflect most of the sun's heat. Dark-colored clothes absorb most of the sun's heat and hence we feel more comfortable wearing them in winter.